Welcome to another Screencastify video. Today we're going to look at x-intercepts and their multiplicity. But before we start that, I wonder how many of you on your winter session within the past year or two would know where or what a Yucca brevifolia is. So if any of you traveled with John Dowd to Joshua Tree, that is the actual name of Joshua Tree is Yucca brevifolia. So let's get down to business. So the first two graphs we're going to look at, in essence, look the same. So x times x minus 2, x times x minus 2. But in the second graph, we're squared. So in this first graph, we have an x-intercept at 0 and x-intercept at 2. Well, how does that change when I change the degree? So up here, we have a degree 2 because it's x squared. Here, we have x squared, and this would be x squared. This is degree 4. So we should have 4 x-intercepts. But let's look to see what happens. I don't have 4 x-intercepts. I have 2 because I have 2 x-intercepts at 0. I have 2 x-intercepts at 2. These are called double roots. And a double root doesn't pass through the x-intercept like a single root does, but what it does is it comes down, it hits the x-intercept, and it bounces back up. It comes down to the x-intercept, and it bounces back up. I want you to please look at what shape does that make as it does its bouncing. Doesn't it look like a parabola? So within each of those double roots, it looks like the quadratic that you would see in its, if you were to look at each of those x-intercepts separately. So now what I'd like to do is to quickly take a look at what happens when you have a triple root. So now we're going to look at a triple root, and I'm going to look at 3 separate graphs. So here is our triple root at 0. So we have 1 root. Notice that it goes up to that x-intercept. It kind of flattens out a little bit, and then it goes up. Here I'm going to have an x-intercept at -2. Here I'm going to have an x-intercept at 0 and 3. So let's actually look at this last one last. So here, when we talk about this triple, here we've got x cubed, they're cubic. They both behave like a regular cubic would. A regular cubic is going to come up to the x-intercept, it's going to get to the 0 and twist through it. Our x-intercept at this graph is -2. We get up to that 0, we twist through it. Please recognize that twist looks exactly like x cubed would. So that is called a triple root. So how is that going to look when we're looking at something that's not cubic, something that has a higher degree? Like our last graph that I messed up with. So I'm going to get rid of this one and do this one instead. So in this graph, we have an x-intercept at 0 right there. So we have there's our x-intercept at 0. And now we also have an x-intercept at 2. But please recognize that if I were to multiply this out, first off, I have the x from the beginning, and then I have my x cubed from that binomial. And when I put that together, it's going to be x to the 4th, and that's why we get that W shape. But here is our triple root that bounces through, or that skirts through like x cubed would. I hope this helped. Have a fabulous day. I look forward to talking to you later.